happening at different times. And rains are coming unpredictably with greater intensity. With the timing of reproduction, changes in migration, entire communities of animals are actually reshuffling itself. We now have Dehgan, known as commonly as bone break fever, in Texas as well as Florida. We're seeing new emerging tropical diseases affect us at home. And in talking about diseases, old diseases are progressively being eradicated, but new ones are emerging, particularly at the intersection between wildlife and domestic animals, at the intersection with environmental change. 60% of emerging infectious diseases are zoonotic, and 72% are shared between humans and wildlife. Those include Ebola, plague, and Marburg disease, which are found here within the country. We got 9 billion people that we need to feed by 2020. That's going to require 70% more food and 10 billion hectares of additional land to grow that food on. To do that, that means we're either going to convert the forests or the savannas into agriculture. It also means tripling the amount of phosphorus, doubling the amount of nitrogen, tripling the amount of pesticides, and doubling the amount of irrigated area. But we don't have water. In fact, we see 70% of water actually going to agriculture. And the one thing that we see brewing within this region alone, given huge population growth in Uganda and Ethiopia, is a conflict over potentially the Nile. And what's going to happen between the upstream neighbors of the Nile, who have a huge youth bulge, and the downstream neighbors of the Nile, who are entirely dependent on the Nile. Egypt is not in a great political situation either. Population growth most population growth over the next 50 years will happen in the developing world. 9 countries will account for 45% of the population growth by 2050. Uganda is one of those 9 countries. And it has a population growth rate that's the 5th highest in the world. Coupled with that, we're seeing massive people moving to cities. And in fact, if you're looking at rates of urbanization, Uganda is 3rd in the world for rates of urbanization. Cities provide huge new challenges. You have people living in para-urban environments. So what does that mean in terms of how we're thinking about development? The basic message about these facts is that problems are increasing exponentially, and our solutions have to increase exponentially as well. And science and technology gives us the tools we need. There's a greater recognition that we can harness the power of science and technology to be able to accelerate development, to be able to leapfrog slower and more traditional pathways. And the great advantage that we have is there's a democratization of science that levels the playing field for people around the world. We see with Moore's law the number of transistors on a chip doubling every 18 months. And in fact, the student today that was outside showing their app on malaria has more power in his smartphone and more access to data than President Clinton did at the beginning of his administration. We see cell phone access. It took 20 years for the first 100 million cell phones in Africa, but it only took 3 years to get to 300 million. We see genetic advances in our understanding of how the rules of how the world is governed. When the United States invested in the Human Genome Project, we spent $2.7 billion in 13 years to sequence the genome of a single individual. Today, we can do that for $1,000 in a day. What does that information give us? Well, the fact is in 2011, we produced more data than all of the rest of human history. So how do we actually use these tools and this power? And what does it mean when you're disconnected from science and technology and from that accelerating gulf of knowledge? And we've seen great leapfrogging. So mobile phones, I think, is one example, but in fact, all over this country, and I spent last week actually driving across the country, every corner you see mobile money, which is actually a leapfrog over our own banking systems. There's the power of 3D printing now in Africa to transform manufacturing, to move manufacturing centers from Asia to locally. We've seen how people are using maps and navigation systems. Paper maps are gone. People are actually looking at their phones for navigation. People have stopped looking at encyclopedias and are looking at Wikipedia. And in fact, in higher education, we're seeing a massive transformation through the use of massive open online courses that could be the way to get access to the best professors around the world, to use classroom time for discussion rather than lecture. So how do we leapfrog development? How do we actually build systems of the future? And over the last 3 years, USAID has tried to pioneer a number of new ways to transform how we're doing development. We've started a series of grand challenges for development, and that has led to incredible new innovations that were actually created by undergraduates. There's something called the PrEP pouch that looks like a ketchup pouch that was created by undergraduates at Duke that allows you to prevent the transmission of HIV from mothers to their children around the time of birth because it doesn't require a cold chain. It can be used for remote communities. That innovation got World Health Organization's Top 10 Innovations of 2012 award. It wasn't created by a major research center. It wasn't created by a private pharmaceutical company. It was created by a class of students at a university. And there's huge power in that. And for that, we decided to launch this thing, the Higher Education Solutions Network, in 2012. We wanted to create a set of development labs to help us with data, to help us evaluate technologies. There's 1,000 cook stoves in the world, but how do we actually look at the performance characteristics, the sustainability and suitability of those things? How do we actually incubate new technologies and make use of the incredible innovators and inspiration that they've provided us today? How do we engage students fundamentally in a different way? We sought to change how universities actually approach development. We wanted them to become more multidisciplinary because development is a systems approach. We wanted to see entrepreneurship as a way of growing problems and actually having sustainable development solutions because they would identify demand. We wanted to create a new field of development engineering, and we wanted to internationalize science around development and create partnerships. We sought to change education because we wanted students to ask not what is your major, but what is your problem? Because that's actually what makes for effective education at the end of the day. And our goal was to create what we created in the United States with NASA, a jet propulsion lab. And in fact, the Jet Propulsion Lab at Caltech is what put Curiosity, the big rover that's currently on Mars. The control center is at the university. It was built with students at the university. The question is, how do we create that for development? Much like Makerere, we wanted to build for the future. And we sought to do it. So we had a global competition. 500 universities applied from 49 states and 33 countries. We ran 50 peer review panels of internal and external peer review of some of the world's greatest experts in science and development. We had a second round of peer review for those competitors that made it through the first round, and we then put them through a pitch session. So out of those 500, we selected 7. 6 of them are in the United States of the lead institutions. One was Makerere University. And I think